In our last tutorial, we discussed Bitcoin and the blockchain. In this tutorial, we'll provide an introduction to smart contracts on the Ethereum blockchain. Ethereum is also a cryptocurrency, but its blockchain comes with one key difference. That difference is that it hosts a virtual machine on each node. This means that the node is able to execute smart contracts or business logic, as opposed to just handling the nuts and bolts of the ledger. We'll introduce some useful tools, and we'll deploy and interact with a smart contract on the Ethereum blockchain. This introduction is useful for two audiences. One, it's useful for software professionals that have experience coding but want to learn the mechanics of how to deploy and operate smart contracts. It's also useful for less technical folks that want to gain an understanding of why this technology is so powerful and will be very disruptive to many industries. I'm Max G. Let's get started. Here are some of the tools we'll be using for this tutorial. Of course, we're going to be using the Ethereum blockchain. We're going to use the Remix Solidity compiler to compile and deploy our contracts to the blockchain. The Remix compiler is a web-based compiler that operates as you would expect an IDE to operate. On the left-hand side, we have a list of files. In the middle, we have the source code for our files. The bottom will have our console that will show our activities as we are interacting with the blockchain and interacting with our contract. And over on the right-hand side, we have various tabs that allow us to set settings, debug our contract, run and compile our contract. We're also going to be using the MetaMask Chrome add-on. This is a Chrome add-on, also compatible with Firefox, that allows our browser to interact with the Ethereum blockchain. We're not going to be running our tutorial on the live Ethereum blockchain. We're going to use the Ropsten Ethereum testnet. This is a testnet that is fully functional, operates very similar exactly as the live Ethereum blockchain, except it doesn't require real Ether. This allows the community to develop and test, deploy contracts in a test manner without having to spend real Ether. We're going to use Etherscan, the Ropsten subdomain of Etherscan, to view our contracts and the transactions as they occur. I'll also be using Microsoft Code. I don't compile or deploy within Microsoft Code, but this is just a little bit easier interface, easier interface for you to be able to view the code as I walk through it. The use case that we're going to use for our tutorial is a multi-beneficiary trust fund. This is a pretty straightforward example, but I think it will go a long way in showing the benefits of Ethereum as well as the mechanics of how we're going to deploy contracts, develop and deploy contracts. So for a multi-beneficiary trust, we're going to set it up as a contract where the owner of the contract is allowed to add or remove beneficiaries of the trust. The beneficiaries can request withdrawals from the trust. And when a withdrawal occurs, all the beneficiaries will receive the same amount. We're also going to show a trustee-controlled multi-beneficiary trust fund. This will be the same as the first trust that we show, except we're going to we're going to set it up so that only trustees that are assigned by the owners can request withdrawals. And this will make a little more sense as we get into it. In order to understand some of the players in our use case, we have established our bear family. So we have 6 members of our family: Mama Bear, Papa Bear, Grandma Bear, and 3 baby bears. Mama Bear is going to be the trust owner. Papa Bear is going to be a trustee as well as a donor to the trust. Grandma Bear is going to be a donor to the trust. And Baby Bear 1, 2, and 3 are all going to be beneficiaries. This will make more sense as we get into it. So let's take a look at our bear family within MetaMask. I've already created the accounts on the Ropsten testnet. We have Papa Bear, Baby Bear 1, 2, 3, Mama Bear, and Grandma Bear. before we get started, we will give Mama Bear a little bit of ether, test ether from the Ropsten faucet. So to do this, you copy the address from MetaMask, go to the Ethernet faucet site, just paste your address here, and click the Send Me 3 Test Ether button. This will send about 3 ether to each account in the list about every 7 seconds. So while that's being mined, let's go take a look at the code. Here's the code for our multi-beneficiary trust contract. Solidity is very similar to JavaScript. For each contract, we use the contract keyword followed by the name of the contract. This contract has 3 members: the trust name, the owner, and an array of addresses representing the beneficiaries. The first function we have here is the constructor. It accepts the trust name and simply sets the public member to that trust name, and it sets the owner to be the sender for this transaction. And that owner is going to be the owner for this instance of the contract. The second function that we have is one that registers the beneficiaries. The first step that we do is require that the sender is equal to the owner. This ensures that other transactions or other senders on the Ethereum network are not able to add beneficiaries. If another sender besides the owner were to call this function, it would error out on this call, on this line. The second step is to add this beneficiary to add this address to the beneficiaries array. The third function that we have here is to deposit. This is a very simple function that just allows anyone on the network to deposit funds into this contract. Finally, we have the withdrawal function. This accepts a percentage between 0 and 100, and it loops through the list of beneficiaries and will transfer the amount to each beneficiary. You'll see that I first take the balance of the contract, represented by the keyword this.balance. I save that in a variable. Then as I loop through, I take the before balance divided by the length of the array, or the number of beneficiaries. I multiply that by the percentage divided by 100. This ensures that each beneficiary is going to receive the same amount of funds and that the contract will never be overdrawn. All right, so now Mama Bear has a little bit of test ether to deploy her contract. What we'll do is just copy our code here, and we'll paste it into Remix. And what we'll do here is go to the Run tab. We'll make sure that we are deploying this to the Ropsten testnet. We'll make sure that the account is Mama Bear, so it is 0x7D. Here, 7D, that's right, okay. And we will here enter in a trust name. We'll use Mama Bear's Trust. Up pops MetaMask. We'll submit. And you'll see down here in the console that it has submitted that transaction to the network, and here it's pending while we are waiting for that contract to be mined. All right, now that the contract is mined, we have a confirmation coming back in the console. It reports back the block and the transaction index for this contract. So the first thing we'll do is add some beneficiaries. Here we can confirm, click Trust Name, and we get back Mama Bear's Trust as the name that we entered. We can also click Owner, and that confirms that Mama Bear, her address, is the owner of this contract. For ease of use, I put the just created a text file here with all the addresses of our bear family. So I will enter the address into the text box beside register beneficiary. It likes the address to be in double quotes, and then I will click the register beneficiary button, submit that transaction to the network. And while that's being mined, I will go ahead and add Baby Bear 2 and Baby Bear 3 as beneficiaries as well. It is asynchronous, so we don't have to wait for the console to report back before we register our additional beneficiaries. So here are our pending transactions for the 3 beneficiaries. We can also go ahead and deposit funds into the trust, into the contract. So for that, we'll enter a value in the up at the upper right-hand corner of Remix, and we'll go ahead and deposit 1 Ether. 1 Ether, and we will click the deposit button. Submit that transaction to the network. And here you can see I called register beneficiary 3 times, and I got 3 confirmations back. And here we'll see that the deposit is pending. While that's going, we will go ahead and select go look at the contract on Etherscan. So in the MetaMask history for Mama Bear, we'll see our transactions, including the contract published transactions. We'll just click on that, and that will open Etherscan for us to view our contract using the web. Etherscan shows the from address, that's Mama Bear's address, and for the to value, it gives us the address of the contract. So we can click that. And that opens up the transaction history for this contract. Here's the contract address. Here's shows 1 Ether that we deposited to the contract, and it shows the history. 3 minutes ago is when we created the contract, and then you'll see the 3 calls to register beneficiary, and finally the call to the deposit function. So now what we'll do is switch to Baby Bear 1, and we will request a withdrawal from the contract. When you change the account within MetaMask, you'll need to refresh Remix so that the appropriate account shows in the upper right-hand corner. So we'll refresh. It'll then attempt to recompile this contract. So since we're now in Remix as Baby Bear 1, we do not have the contract history that Mama Bear created. So what we'll have to do is load that contract from its address. To do that, we'll go to Etherscan, copy the contract's address, come back to Remix, and we will paste the address into the text box here. We'll click the address button, and that brings us back to our function buttons that allow us to interact with the contract. So I can click Trust Name, get back to Mama Bear's Trust. That's the name of our contract, name of our trust. And here is the owner. Again, that's Mama Bear. And what we'll do is we will request a withdrawal from this contract, and we'll do 50%. So here we'll click Withdraw. And here you'll see it's Baby Bear 1 that's requesting this transaction as opposed to Mama Bear. And we'll click Submit to send that transaction to the network. And we'll just give that a second while that transaction is being mined. All right, that transaction's now been mined. We'll come back to Etherscan. What we'll do is refresh Etherscan on our contract address, and we'll see that our withdrawal transaction is now showing. So we can click on that transaction, and this shows who called the transaction, the withdrawal function. You'll see it's baby bear 1. That's the address for baby bear 1. And then there are 3 internal transactions that we can view. It transmitted 1.666666 Ether to baby bear 1, the same to baby bear 2, and the same to baby bear 3. That works. That's just as our trust is established. Essentially, there was 1 Ether in the contract before we handled the withdrawal, and now you'll see there's 0.5 Ether, and it transmitted the appropriate amount to each one of the baby bears. We can confirm this by checking the accounts within MetaMask. So baby bear 1 now has, he had some additional Ether, about 0.4 Ether, 0.5 Ether in there already. Baby bear 2 and baby bear 3 had variably nothing, and now they have the 1.666, that's correct. And baby bear 3 also has the appropriate amount. So there we go. That shows that our contract, our smart contract, operated as we would expect. At this point, we've introduced Solidity, Remix, MetaMask, and Etherscan, and we've performed the simple mechanics of deploying and interacting with a smart contract. In just 36 lines of code, we created a trust, handled beneficiaries, deposits, and withdrawals. The key principle as we compare this trust fund on the Ethereum blockchain to legacy trust funds is that we rely on no centralized organizations. We rely on no government, no courts, no lawyers, no third parties. Everything is hosted in the Ethereum blockchain, which is completely decentralized. You may have noticed that our simple trust fund allows for anyone on the network to execute withdrawals. That's probably not what we would desire. In the real world trust funds, trustees are assigned to manage withdrawals. So let's go back to our smart contract, and let's add support for trustees. So let's take a look at our code for the trustee-controlled multi-beneficiary trust. Similar to before, we have our contract construct. We have 4 public members this time, the trust name and owner just as before, the array of addresses to represent the beneficiaries just as before. And what we've done here is we've added a mapping that maps the address to a Boolean, and this mapping will represent our trustees. Where the address is mapped to a true, that'll be denoted as a trustee. Any other address mapping to false would not be a trustee for this contract. So the constructor, the same as before, except at the last step of the constructor, we register the sender, the owner of this contract, as a trustee themselves. The second function that we have is to register the trustee. So here again, we require that the sender is the owner to make sure that no one else is registering trustees or beneficiaries on our behalf. And here in our mapping, we set the mapping of this trustee address, which we pass to the function. We set that value, that Boolean value, to true, so that we know that this address is an authorized trustee. We've also added an unregistered trustee function, which is essentially the same as register, except we set the value to false. For registered beneficiary, it looks exactly the same as before. And now we have added an unregistered beneficiary function, and that would be just in the case that, let's say, one of the beneficiary passes away or something else happens, so that the beneficiary is no longer going to be receiving any funds from this smart contract. And here again, we require that the sender is the owner. And what we do is we loop through all the beneficiaries in the array until we find the beneficiary that we're looking to unregister, and simply delete that beneficiary from the array. The deposit function operates the same as before. The withdrawal function, again, operates just as before with one important change. We've added a require statement that just requires that the caller of this function, this withdrawal function, is a trustee. So it simply looks in the mapping for trustees. It looks for this address of the sender, and it requires that that be true. So if anyone else is invoking this withdrawal method, this line would fail and no withdrawals would occur. One point I want to make, it's a bit technical, so bear with me. Now I made the trustees a mapping as opposed to an array. The reason I did that is because there's no need in our use case to loop through the trustees. Within Solidity, there's no way to loop through a mapping. It's simply looking at the address and determining if it's true or false. However, the beneficiaries must be an array because we must loop through the beneficiaries when we do the withdrawal because we have to touch each one. This allows us to use less gas, less computational power as we're operating and interacting with our contract. Let's give it a try. So I will copy the code here. I'll go back to Remix. Actually, I'll go back to MetaMask. I'm going to create this contract from Grandma Bear. So we'll select Grandma Bear within MetaMask. Then we will refresh Remix. Go into the trustee controlled. What I'll do is just copy and paste our code just to make sure it's the most up to date. I will go to run. This is Grandma Bear's account. She has 11 Ether. And what we'll do is create this trust. We'll put in a name here, Grandma Bear's Trust. We'll give that a second while the trust is being mined. All right, now that the trustee is mined, we are going to handle a series of transactions with this contract. The first thing we'll do is check the name, Grandma Bear's Trust. That's correct. And we will register each baby bear as a beneficiary. Back to my addresses here. And I'll select each of baby bear's address. We will register the beneficiary. Register baby bear 2. Again, it's all asynchronous, so we don't have to wait for the transactions to be mined. Now I'm also going to register Papa Bear as a trustee. So we will select Papa Bear's address here. And we'll find our register trustee function. Again, it likes the addresses in double quotes. We'll register the trustee. And we'll also do a deposit. So let's deposit 1 Ether to the trust. While that's being mined, we will go look at our contract on Etherscan. So here I'll scroll down till I find the contract published transaction. Just click there and it will open that contract on the Ropsten Etherscan site. Here again, from is from Grandma Bear, and here's the contract that we created. I'll click there. And here's the series of transactions. It looks like it's still being waiting to be caught up. Give it a refresh. More select, more show up here. So we've created the contract. We registered 3 beneficiaries. we registered Papa Bear as a trustee, and we performed a deposit. Now, since this is a trustee-controlled trust, we're going to try to trigger a withdrawal from Baby Bear's account. So we'll go to MetaMask and switch accounts to Baby Bear 1. We will refresh Remix so that it uses Baby Bear's account. Now we will have to load this contract from the address, since we are interacting not from Grandma Bear but from Baby Bear's account. Load the contract from an address. Okay, and we can select, see, our owner is Grandma Bear, trust name is Grandma Bear's Trust, and here let's try to trigger a withdrawal. And here we go. Here it shows that we got an error. Now the error message is not particularly useful in this case. The key part here, it says an important gas estimation might also be the sign of a problem in the contract code. Please check loops. Be sure that you do not send a value to a non-payable function. So that is not the best error message, but that's the that's a side effect of using technology that's somewhat new. As we went in and further made our smart contract more bulletproof, we'd be able to add better error handling, better messaging there. But let's go ahead and switch to Papa Bear's account and try to trigger a withdrawal from Papa Bear's account. He was registered as a trustee, so it should be able to go through. So I switched to Papa Bear in MetaMask. I'll refresh Remix, go back to the Run tab. I'll have to select the contract from, load the contract from the address. That's Grandma Bear's Trust, that's right, okay. And we will, here in the withdrawal button, type in 50% and withdraw. That looks good. Coming up here, confirming the confirmation. Again, I'm calling from Papa Bear's account, who is a trustee of this trust, and we'll submit it. And while that's going through, we'll just go back to Etherscan and take a look. Waiting for it to be mined. The fact that it did not give us that error message right away is a great sign, and there we go. We have our confirmation that it's now been that transaction has been mined. It should show up on Etherscan, and there it is. So let's take a look at that transaction. Great. Now it's being called from Papa Bear's address. He's the 251, and you'll see the 3 internal transactions. 0.1666666 Ether went to Baby Bear 1, Baby Bear 2, and Baby Bear 3, just as we expected. Let's take a look at the Baby Bear's accounts. They should now show a higher number. Yep, there we go. It was 0.17 or 0.21 before for Baby Bear 1. Baby Bear 2 was 0.16 before. Now it's showing 0.33. Perfect. So that shows both that our multi-beneficiary trust worked as we expected, and now our trustee-controlled multi-beneficiary trust worked as expected. Let's talk about some of the benefits of our trust. The most important benefit of using blockchain and smart contracts is that all of our operations are decentralized. It means there's no need to trust intermediaries. In our example that we performed today, there was no need for any governments, courts, banks, lawyers, or any third parties besides the Ethereum network, which is completely decentralized. Also, convenience. There was clearly less work to manage transactions when you have multiple donations going to multiple beneficiaries. It's far fewer transactions when we're using a trust. Another example is that this contract has an open address for donations. So let's say that you were a nonprofit organization and you had missionaries or other non-governmental organizations around the world, and you wanted to manage donations in a central or manage donations for each of those missionaries. You would be able to set up this contract, and you would be able to publish the address publicly to your congregation, to your community, online or in person, and then any of those folks could donate into that trust. Also, the cost. So in the sort of the legacy trust fund world, the estimate to create a trust is about $2,500. That's just a basic paperwork from a lawyer to set up a trust fund. Most trusts would probably even cost more than that. Now, there's also significant benefits in the transaction costs of using the trust over using just basic transactions within Ethereum. So let's take a look at that. So let's say that you have 350 donations going to 19 beneficiaries with an average transaction cost of 50 cents. Without a trust, you would have to manage 6,650 transactions, which is essentially just your number of donations times your number of beneficiaries. At 50 cents each, that would cost over $3,000. Now, to manage those with the trust, it would be 370 transactions, which is essentially your donations plus your beneficiaries plus one, because there is that additional transaction to get the funds to withdraw the funds out of the trust, and that will operate at a total cost of $185. So clearly, significant savings in gas and transaction costs to use the trust as opposed to not using the trust. In subsequent chapters of this tutorial, we'll do a handful of additional activities. First, we will integrate this smart contract into the Truffle framework. The Truffle framework will allow for some additional rigor around our DevOps processes, as well as some additional testing that we can perform. We'll also integrate with Uport for identity management. This will replace some of the activities of MetaMask so that all of the members of our Bear family will not be managed under one password within MetaMask, but each member of our Bear family will have their own identity managed through Uport. We'll also develop a front end. So clearly within Remix, the way that we interact with our smart contract is rather technical and not very user-friendly. So what we'll do is put a front end on it so that interacting with the trusts will look more like a sort of a legacy bank website, very user-friendly, so that non-technical users can log in, create trusts, manage their beneficiaries, manage their trustees, perform deposits and withdrawals. That's a wrap for this tutorial. If you're a software professional, I hope you learned a little bit about the mechanics of how to deploy and operate smart contracts on the Ethereum blockchain. If you're less technical, I hope you were able to catch just a glimpse of the tip of the iceberg of why this technology is so transformative. In future tutorials, we'll integrate Truffle framework for improved DevOps and more robust testing. We'll integrate Uport for identity management, and we'll add an interactive, user-friendly front end. I'm Max G. I'll see you next time.